For this lesson, sizobe discuss dependent events. We are still discussing tree diagrams. In the description box, there are links for amanyama lessons related to probability grade 11. Now, what are dependent events? Dependent events they are the opposite of independent events. Dependent events, they are dependent on each other, right? Whatever happens in the first event, what happens in the second event will be dependent on what happened in the first event. Same goes with the third event. If a third event occurs, it will depend what happened to second and first event. So nasi define dependent events occur when the outcomes of the first event do have an influence on the outcomes of the second event. Same goes with the third event, fourth event. So if a third event occurs, it will depend what happened to second, now go first event. Go fourth depends on what happened to third, second, and first event. Now, how do we calculate dependent events? Definitely, as we calculate just like independent events. If ever we bukele this video, yama independent events in the description box, you saw what I've done lapha. I'm successive events. Events A and B, the probability of A and B is equal to the probability of A times the probability of B. But for dependent events, A and B, this is not true. So how do we calculate them? We introduce something called a conditional probability. Probability, right? So for successive dependent events A and B, the probability of A and B is equal to the probability of A times the probability of B with a conditional probability given event A, right? So we have a probability of B, but it depends what happens on A. Yes? Now, this thing is a demonstrator using an example. So for example 1, there are 6 green pencils and 5 purple pencils on a table. So prepare a rough sketch la. This one. Now my pencils were corner. Green, I6. My pencils I6 are green. Purple, I5. Right? So in total there should be 11 of them. Yes? 11 of them. Alright. But James uyavela ke manje. He removes a pencil from the table and does not replace it. Let's say uthatha green. Nangabe uthatha green, let's say mhlawumbe umfaka maybe ku pencil case yakhe. Uthatha lo green umfaka ku pencil case yakhe. Uthatha these pencils at random, ne? At random. So let's say uthatha green, for example, umfaka ku pencil case yakhe. Yabona? He then removes another pencil. Let's say this time uthatha purple ke manje. Yabona? So the more athatha ma pencils from the table, the number yenzani ya decrease. So for the first row sibana 10. For the second row sibana 9. Yabona? Sibana 9. So each time I remove athatha a pencil from the table, the number or let's say the sample space. This is the sample space. The total number of pencils within the sample space it's 11, but the more I remove a pencil, the sample space yenzani ya decrease. I think it's best to ngichaze kanjalo. Okay. Now sample space, James removes a pencil from the table and does not replace it. He then removes another pencil, but destroy a tree diagram. Sorry. Now, tree diagram here tonight. tree diagram yethu. Two things can happen. Somewhere here. Okay, so two things can happen. Ne? Nakayothatha pencil from the table, two things can happen. It's either ngathatha the green one or the purple one. Yes? So let's say, okay, for the green one, kuma tree diagrams wethu kwamele sikhombise nama probabilities. We know that the probability for any given event is equal to the number of outcomes for that event divided by the number of outcomes within the sample space. So the sample space in 11 outcomes for the first row. If ngithatha the green one, what is the probability of taking out the green one? It should be the number of outcomes for that event. So the event for the green ones, it's 1, 2, 3, 4, 5, 6. So it should be 6 over 11. 11 buyapi, it's the sample space. The outcomes in the sample space are 11. For the purple one, it's going to be 5 over 11. Yabona? So na event yokuqala la seyenzekile ke manje, ne? One of the pencils for green or even purple. Okay. Alright, 9 things I'm going. So for the sample space, nangabu event area yenzeka, it's either purple or green uzohamba, meaning that the sample space is decrease kuyoba ubani, kuyoba 10, ngoba the green or the purple seyihambile. Angisho. Now, bese siyabuya ke my second event. For the second event, 9 things ayenzeka ke. 9 things ayenzeka. Something like this can happen. If ever uthethe the green one, after taking out the green one, akasayibuyiseli le green, angisho. So it means that the number of green pencils yenzani ya decrease. Sekasalana like 1, 2, 3, 4, 5. So it means that the probability la kuzoba 5 over 10. 5 over 10. Eish, the color angithandi man. Angithandi the color. It's too bright. Too bright. Black. So the green, it's going to be a green and a purple again. So nangabe keep a green, it means that so cancel green a1. So salana ngaki na 5 out of 10 ngoba green seyiphumile already. Angisho. Ingaphakathi kwe pencil bag. So if ukhethe a green, what is the probability of getting a purple again after taking out the green? So for the purple you about 5 out of 10. If ngithethe a green, the number of purple remains the same. It remains the same. If ngithethe a purple again this time, if I took out a purple, the number of greens remains the same. You have 6 over 10 green lana, and then for the purple it's going to be 4 out of 10. Begai 5 for my purple. My purple begai 5. I take out a purple kusala 1, 2, 3, 4. So for the second row I only have 4 options out of 10. Out of 10, so it's purple. Then you need to show imilenze yakho. Green, 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 purple, purple, green, purple, purple, or outcomes. These are your outcomes. These are the outcomes. Yeah. These are the outcomes. So for the first question, determine the probability that both pencils removed are purple. So first row purple, second row purple. So both pencils drawn are or removed are purple. So our probability now, our outcome now, PP. So the probability of getting a purple and then another purple is going to be equal to, we use this formula le. Basically siyawa multiply lama probabilities la, but mawuthatha ukubheka la uyabona ukuthi for the second event it depends what happened previously. Uyabona, if this was my probability then I chose a purple, then the sample size here decrease to 10. So that's why siba a conditional probability lapha. So P and P is going to be equal to the probability of P times the probability of P times the probability of P with a conditional given probability ka P. Nabo P abaningi lapha, but anyway we say 5/11 times 4/10. This probability times this one sinikeza ngayiki ke 5/11 times 4/10. Our answer is 2/11. 2/11. Then B. Both pencils removed are green. G. So G and G should be equal to 6/11 times 5/10. 6/11 times 5/10. It's 3/11. So it's 3/11. 3/11. C. A green and a purple pencil is removed. A green and a purple. Okay, abasitshela ukuthi in what order, in what particular order basho. So green, purple, this one, purple, green, this one. So it's not two yama outcomes la. It's this one as well as this one. So therefore the probability of getting a green and purple, okay, it's not two yellow options, green and purple or purple and green. Ngoba lawo ma events lawo, it's either ungathatha i-green kuqala ulandele nge-purple or ungathatha i-purple kuqala then ulandele ngani nge-green. So lana sina purple and green, purple and green. So you are add lama probabilities, voila, the product of these probabilities, we add them with the product of these probabilities. So for this one, 6/11. 6/11 times 5/10 plus 5/11 times 6/10. We get, how much do we get? 6/11 times 5/10. Then here we are city plus 5/11 plus times 6/10. 6/10 answer it. 6/10 it's our answer. And then with D, but at least one green pencil is removed. At least one pencil is removed. Alright, the question iti thola ama probabilities where at least one green pencil is removed. Okay, the word at least iti it's either bakhiphe one or more. Ima outcomes from the tree diagram. It's this one, lana there's two, at least two. I mean, okay, it's at least one, ngoba kuna two, right? It's either but remove a one purple, wait, but at least one green pencil. No, it's not this one. At least one green pencil, it's this one. Laba remove a two, yeah, so at least one. So if I two, that's good. If E1, it's still fine. It's at least one. It's either one or more. So there's green lana there's another green. So now my outcomes are I3. So for D is the probability of G and P, or P and G, or green and green, is equal to green and then P. It's 6/11 times 5/10 plus P, purple and green, it's 5/11, no, 6/10 times 6/10 plus green and green, okay. Esibheka ngiphambanisele izinto. Iphi green, well, it's 6/11, then 5/10. Perfect. Then nayi lapha green and green now, green then green, 6/11 times 5/10. Iyafana na this one. So I thought ukuthi ngithethe the same thing. So lana it's 6/11 times 5/10 plus 5/11 times 6/10 plus 6/11 times 5/10. Answer, it's 9/11. Please check ale calculation ukuthi ngilenze kahle onjani na. But this is how you tackle dependent events, right? What happens in event A will affect what happens in event number 2. Same goes with event number 3. So I hope you told some value out of this video here today, this lesson. In the description box, please check it out. There are other lessons I feel like ungaba interested kiwo azokunceda to understand the probability ka grade 11 much better. So please do yourself a favor, we check, So for now, guys, thanks for tuning in. Asibonane on the next lesson. Bye bye, peace.